Alright class, so we are going to start second chapter, revision of second chapter, that is chemical changes and reaction. Alright, so whenever energy is supplied to or taken out of matter, it always brings about one or the other kind of change. The heat energy of the sun causes evaporation of water. The water vapors on losing heat energy at high altitudes change to clouds or snow. So from this example, it is clear that some kind of change always takes place in the matter when subjected to energy changes. Alright. So in this chapter, we are going to elaborate chemical changes. Alright. So what is the definition of chemical changes? Basically a change which alters the specific property of materials by bringing about a change in its molecular composition followed by the change of state, alright, is called a chemical change. Here when oxygen combines with hydrogen, they together form water. And how they will form water? By their molecular composition, by altering their molecular composition. Alright, so this is a chemical change. So now I am explaining you few points regarding chemical changes. Alright, so first point, a chemical change results in the formation of at least one or more new products. So students, in this example, in this change, the arrangement between the molecules of carbon, hydrogen, oxygen breaks. The hydrogen and oxygen atoms separate out. The hydrogen and oxygen atoms separate from carbon and form water, and the carbon atoms are set free and are left as a black residue. So in this example, when we heat sugar substance, it will break down into carbon and water vapor, and as these substances are new, so we can say that a chemical change result in the formation of at least one or more new products, and thus this heating of sugar is a chemical change. All right. Next point is the weight of the substance undergoing chemical change usually changes. So from this example, during the heating of sugar, the weight of black residue is far less than the actual weight of the sugar. So in this example, during the heating of sugar, the weight of the black residue, this carbon residue, is far less than the actual weight of the sugar. However, this is an apparent change in the weight if we take the weight of steam also. If we take the weight of steam into account and add it to the weight of carbon, then the total weight will be equal to the weight of the sugar crystals. Alright, thus we can strictly speaking, the total weight of substances taking part in a chemical change remains constant. However, in some reaction, it is only seems like the weight of the substance, it is only seems like the weight of the substance change, but in actual the total weight of the products is equal to the total weight of the reactants. All right. And the next point is the chemical change. The chemical change is permanent and irreversible. It means the change will not reverse by altering the experimental condition. For example, in this example, like we are heating the sugar, we are heating the sugar and getting black residue and steam. If we combine this black residue along with steam and we cannot get back the sugar by cooling these products. Alright, so the sugar which has decomposed on heating to form carbon and steam will not change to sugar on cooling. Alright. Alright, so the student, next point is during chemical change, energy is either absorbed or given out. Alright, the various atoms in a chemical compound are joined by electric forces commonly called bonds. Alright, The making or breaking of bonds always requires energy. The making or breaking of bonds always requires energy. The energy required to make a bond between two or more atoms is generally not equal to energy required to break the bonds. So, in this case, some amount of heat is either absorbed or given out during a chemical change. Alright, class?